Big Boy was the largest steam engine ever built, stretching 133 feet from front to tender and weighing over 1,000,000 pounds. It was destined to haul massive freight across mountains and long distances, something no other locomotive could do on its own. Every part of it, every piston, every wheel, every roar of the boilers screamed power. And yet, as mighty as it wasn't invincible. One small mistake, one moment of misadjustment, and this mechanical giant could, and nearly did, kill the very crew who trusted it to get them safely through the mountains. In the mid-20th century, American railroads faced a simple problem. Freight loads were growing heavier, mountains were steeper, and conventional locomotives simply couldn't keep up. Railroads needed something that could pull more cars more efficiently and over longer distances, without having to couple multiple engines together. Big Boy was the answer. A 4884 articulated marvel that could handle what older steam engines could only dream of. It was faster, stronger, and, in theory, safer. But the sheer scale of Big Boy came with risks. The very features that gave it unmatched power also made it unforgiving. If anything went wrong, there was no margin for error. And when a derailment did happen, it was catastrophic. One of the most infamous incidents involved Big Boy 4005, which went off the rails and collided with its own tender. The cab was destroyed, and tragically, the crew didn't survive. It was a grim reminder that even the most powerful machines aren't immune to disaster, and that the men who operated them were as much a part of the story as the steel and fire they commanded. And while these locomotives have been preserved, with Big Boy 4014 even running again today, the story of the dangers they posed and the lives they claimed remains a haunting part of their history. So how did a locomotive this massive, this powerful, almost kill the people who rode it? That's the story we're going to explore today. By the 1940s, freight on American railroads was becoming heavier and heavier, and the mountain routes across the Rockies and the Wasatch were pushing conventional locomotives to their absolute limits. Trains were getting longer, coal and raw materials were moving in greater volumes than ever before, and railroads faced a problem. To move these massive loads, they either needed to hook together multiple locomotives, or risk slowing traffic and overworking their engines. Both options were inefficient. There had to be a better way, a single locomotive that could handle more, go further, and do it reliably. That's where Big Boy came in. Big Boy's 4884 articulated design was about solving a real operational challenge. Imagine it as two locomotives joined in a single frame, with two sets of driving wheels, working in concert to transfer the engine's massive power to the rails. That design allowed the locomotive to grip the tracks and pull enormous loads over steep grades without the risk of stalling or slipping. What railroads got was just brute force. Fewer locomotives meant fewer crews, fewer stops for fuel and water, and smoother, faster transit over some of the country's toughest terrain. The engineering behind Big Boy was meticulous. Its massive boiler could generate a continuous stream of high-pressure steam, powering two huge sets of cylinders in perfect rhythm. The articulation allowed the enormous engine to navigate curves that would have been impossible for a rigid frame locomotive of comparable size. In short, every element of its design was calculated to move as much freight as possible, with fewer interruptions and less strain on both the machine and the crew. Operationally, Big Boy was revolutionary. A train that might have required 3 or 4 conventional engines to traverse a mountain pass could now be handled by a single Big Boy. This consolidation saved the railroad significant time, manpower, and fuel. It also simplified scheduling and reduced wear on the tracks, because fewer locomotives and fewer starts and stops meant smoother operation across big, heavy haul routes. The scale of this innovation can't be overstated. For crews and managers, it changed the way freight was moved across the West. Even the wheels and axles were carefully designed to handle enormous stress. Each driver transferred thousands of pounds of force to the rails, and the balancing had to be perfect to prevent damage to both track and locomotive. Big Boy also introduced improvements in lubrication, braking, and steam distribution, making it as reliable as possible given the scale. Maintenance was another area where innovation mattered. Unlike smaller locomotives, Big Boy required specially designed facilities and tools. Crews had to understand its complexity down to the last valve and rod. It wasn't a locomotive that could be figured out on the fly. It demanded planning, skill, and attention, a reflection of how advanced and interdependent its systems were. By the early 1950s, Big Boy had proven itself as the ultimate freight hauler, a machine built to conquer mountains and move massive loads. But even the strongest engine has its limits, and in April 1953, those limits were tested in a way no one expected. Union Pacific 4005 was pulling a long freight train across southern Wyoming, moving steadily over the high plains at roughly 50 miles per hour. The locomotive itself was a marvel, 133 feet long, over 1 million pounds, with a design that allowed it to haul trains that would have required 3 or 4 smaller engines. It had done the work reliably for years, but that morning, a routine switch was misaligned. The result was immediate. Big Boy 4005 hit the switch, and despite the engineer's quick action on the brakes, the train couldn't stop. The locomotive derailed, tipping to one side as its tender collided with the cab. The first dozen freight cars piled into each other in a chaotic mess. Rails, ties, and ballast were scattered for hundreds of feet. In that instant, raw power became a hazard. The very size and strength that made Big Boy so impressive also made it unforgiving. The human cost was devastating. The engineer and firemen in the cab were killed instantly. A brakeman pinned under debris died later from injuries sustained in the wreck. Investigators later determined that the misaligned switch had been part of routine work by a track crew assisting a local livestock crossing. A small error in judgment, a fraction of communication, and suddenly 1 million pounds of steel became a deadly machine. It was the combination of human error and enormous power. For decades, Big Boy had symbolized strength, innovation, and reliability, but in one moment, it also became a symbol of risk. For the men who operated these machines, it was a lesson learned the hard way. No matter how advanced or well-engineered, the biggest and strongest engines could turn lethal under the wrong circumstances. Big Boy was an engineering marvel, but it wasn't invincible. To understand why it could be so dangerous, you need to look at what made it extraordinary in the first place. Its size, weight, and design were all intended to maximize power and efficiency, but those same traits also introduced vulnerabilities that could be deadly under the wrong circumstances. Start with inertia. Once it was in motion, stopping it required immense force and time. Brakes could slow it, but they couldn't defy physics. A fully loaded Big Boy on a descending grade could carry enough momentum to overpower any emergency brake attempt. That kind of mass doesn't forgive mistakes. Even a small misjudgment in speed or distance could escalate into disaster before the crew had a chance to react. Then there's the articulated design. Big Boy wasn't one single rigid frame. Its 4884 configuration meant 2 sets of driving wheels under a single boiler, connected by a flexible hinge that allowed the locomotive to navigate curves. Articulation was brilliant engineering. It let a locomotive of unprecedented length handle tight mountain grades, but it also added complexity. Each set of wheels had to stay perfectly aligned with the rails, and each articulation point was a potential point of mechanical stress. A misaligned switch, a poorly maintained track, or even a sudden shift in load distribution could push those joints beyond safe limits. In other words, Big Boy's flexibility was both a strength and a vulnerability. Add enormous momentum to the mix. Every movement of the locomotive carried the cumulative weight of its massive boiler, tender, and loaded cars. That meant that minor errors could be amplified catastrophically. The very features that allowed Big Boy to haul trains solo over mountains also meant that it could barrel into danger with unstoppable force. crew reaction time was limited, and the sheer scale of the machine could turn an everyday operational decision into a life or death situation. And finally, there's the contrast between raw power and fragility. Big Boy's boiler could generate over 7,000 horsepower, and its driving wheels could grip rails with incredible force. Its firebox could sustain massive steam pressure for long hauls, and its tender could carry thousands of gallons of water and tons of coal. Yet, all that power existed on a razor's edge. Wooden ties, steel rails, and human judgment were the only things keeping the locomotive from disaster. Any failure in track, signaling, or even routine maintenance could have devastating consequences. What made Big Boy mighty also made it unforgiving. It's a paradox of engineering. The very features that defined Big Boy as one of the greatest steam locomotives in history were the same ones that could turn it into a deadly machine. The derailment of 4005 illustrated this perfectly. A misaligned switch, an otherwise routine operational oversight, and suddenly the world's most powerful freight locomotive became a wrecking force that claimed lives. The scale of the machine left almost no room for error, and its speed and momentum turned what might have been a minor incident for a smaller engine into a catastrophe. Big Boy wasn't dangerous because it was poorly designed. On the contrary, it was a triumph of engineering. Its risks rose from the combination of human operation and the sheer scale of the machine. It demanded respect, skill, and constant vigilance. For the men who rode it, Big Boy represented both the pinnacle of steam-era achievement and a reminder of the limits of human control over mechanical power. Big Boy pushed the boundaries of what railroads thought was possible in the 1940s and 50s, and even decades later, its impact is still felt. One of the most enduring lessons from Big Boy isn't about size or speed, it's about scale management. Designing a machine capable of moving 1,000 tons of freight over mountains required careful coordination between every subsystem: boiler, wheels, articulation joints, and tender. Every bolt and rivet mattered. This kind of systems thinking influenced later locomotive development, particularly in diesel-electric designs, where engineers sought to balance power, reliability, and maintainability. Big Boy showed that it's not enough to build big. You have to anticipate how that size interacts with its environment. Another lesson comes from the human side of operations. Big Boy demanded skill, training, and precision from every crew member. Engineers and firemen couldn't treat it like a smaller locomotive. They had to respect timing, track conditions, and steam management. Its legacy reinforces an important principle. No matter how advanced a machine, human expertise remains critical. In fact, the crashes and near misses of the Big Boy era prompted railroads to refine safety procedures, signaling systems, and crew training programs. Big Boy also left a cultural legacy. It became a symbol of American industrial ambition. It was proof that engineering could solve immense logistical challenges. The locomotive inspired railfans, modelers, and engineers alike, fueling interest in the mechanics, strategy, and artistry behind railroading. Its size, scale, and aesthetic made it a recognizable icon. Turning it into more than just a machine, it became a story about ingenuity, perseverance, and the quest to overcome natural obstacles. Today, the surviving Big Boys stand as monuments to a bygone era of ambition and engineering. Some are preserved in museums, allowing visitors to marvel at their size and craftsmanship. Others, like 4014, have returned to operational life, thundering across modern rails, a living testament to what was once thought impossible. Seeing one in motion, it's impossible not to feel a mix of awe and respect for the engineering, for the crews who tamed it, and for the lessons embedded in every rivet and wheel. Decades after the last Big Boy rolled off the rails, these giants continue to capture imaginations, not just as relics, but as living symbols of engineering ambition. Of the 25 original Big Boys built, only a handful survive today, preserved in museums or on display for rail fans and historians. But one, 4014, has returned to operational life. moving under its own steam once more. Restoring a big boy isn't like restoring a typical steam engine. Every bolt, every rod, every massive wheel has to be inspected, repaired, or replaced with painstaking attention to detail. Engineers and volunteers spend thousands of hours ensuring the machinery can handle the stresses of movement safely. The restoration was about preserving a machine that represents decades of innovation, design, and American industrial ingenuity. When 4014 moves along the rails today, it's more than a spectacle. It's a bridge between eras, a chance to witness firsthand what it meant to operate a locomotive that could haul more freight than almost any other engine in history. Museums and rail excursions offer people the rare experience of seeing and hearing a big boy in motion. These operational tours and restorations allow new generations to learn from Big Boy's story. They see the balance between ambition and risk, power and precision, and understand why this locomotive still commands respect. In a way, the surviving big boys are teachers, showing us what's possible when engineering, vision, and human skill come together. They remind us that even the most extraordinary machines are not just about size or strength, but about the people and the ingenuity behind them, keeping history alive 1 mile at a time. This story leaves us with a question that lingers long after the whistle fades. Was the ambition worth the risk? Triumph or tragedy? Big Boy embodies both. It's a machine capable of extraordinary feats, yet one that demanded respect, precision, and humility. Now let's hear it from you guys. Which story fascinated you more? The sheer power of Big Boy or the risks it carried? Comment below, hit like, and share this story with a friend who loves epic machines.